Now we want to test our CNV model like it is required in production projects. For this, I delete the existing test harness with ramp and scope blocks. Right-click on the subsystem, go to EverTest in the context menu, and select Create EverTest Harness. The new test harness includes the EverTest source and sync blocks, the EverTest graphical user interface, and the generated Excel file with a sample test case. If I double-click on the test case in EverTest, it will be executed immediately. As we do not have the scope block anymore, I will add the signal viewers for the related signal lines. I right-click on the signal and add a signal viewer over the context menu. It provides the same features as a scope block. Now I add a legend to distinguish between the signals. Execute the test case in EverTest. The output is displayed in the signal viewer. I add the input signal to the viewer, click here on the signal selector, and choose the input signal. Rerun the test case. Now both signals are displayed. I need to define the more specific test values for the test case to verify the CNV requirement. I can define the input values by hand or right-click here and generate them based on predefined design ranges. A new test case was generated. The values start at 0 and go to -60, which is the minimum design value for intent. Then they go back to 0, and then they reach the maximum design values of 100 and go down to 0 again. This test case was generated based on design ranges from the requirement, and it helps me to test it. I can run the test case to see what are the output values. I can dive into the model analysis when I start the debugger in EverTest. The debugger activates the signal labels for each block output and helps me understanding the internal life of my dynamic model. Open the subsystem and run the test case in a debug mode. The simulation pauses at the time step 0. You can see the time step here in the test specification, here in the Simulink editor, and in the EverTest window. You can analyze the model behavior based on the output values of Simulink blocks, input 0, multiplied by 9/5, plus 32. The output is correct, 32. I can now simulate the model in a step-by-step debug mode. Watch how the signals are changing. Now the input is getting to -60. At the output, I have -76. I know it is correct based on unit specification. Just look at it. -60 maps to -76. Go back to 0. The output is 32, fine. Go to 100. It is a maximum input value. The output is 212, exactly what I expected. Move back to 0, 32. EverTest helps me following the production development workflow. Requirements-based testing is a mandatory method of the test generation. For better traceability, I can use the unique requirement ID R1 from the specification. I can just copy exactly this text pattern, disable the library, and place the requirement pattern as a Simulink annotation. I can connect the annotation with a relevant block, like this. It is my requirement link. EverCheck helps correcting the format automatically. Just run it like we have done it in the previous exercise. The format will be fixed automatically. Enable the library link again and save the model. Run the checks. We agreed that the outputs were fine, based on my engineering judgment. I checked every single output here in the debugger, and I know that this output here is correct, and I can reuse it as a reference for my regression testing. I click here on the cleanup button to correct the colors and other format settings in the Excel sheet. It saves me time as I do not have to do it by hand. Now I can show which requirements I test. I add the requirement ID R1 over here in the test case description. On update in EverTest, the requirement ID will appear near the name of the test case. I can also add the goal for my test case. The automatically generated sample test case can be deleted. Now I can activate the rest of the verification methods in EverTest. Static analysis report, structural coverage report, and verification report can be generated automatically. The graphical objects in the EverTest verification report are dynamic, so you can analyze the data by using the cursor, which is synchronized with the test case table. You can use it like an offline debugger, see how data is changing at the specific points. Now you learned how to use EverTest for testing in Simulink.